Chapter 12.1, Day 2, we're still looking at an introduction to limits, but we're going to focus on properties of limits and direct substitution to evaluate limits. So sometimes, as an example 2 from the previous lessons, the limit of f of x as x approaches c is f of c. In such cases, the limit can be evaluated by direct substitution. So we can just plug in c into our x value and figure out what that value is. There are many well-behaved functions such as polynomial functions and rational functions with non-zero denominators that have this property. So here are some basic limits here. And so we'll kind of see this as we plug it in. So I'm not going to go over that too much in detail right now. But let's take a look at the bottom example. We have properties of limits. Let b and c be real numbers. Let n be a positive integer. And let f and g be functions with the limits. So notice with this, because you will see these in the homework, you have the limit as x approaches c of f of x equals L, and the limit of x approaches c of g of x equals k. So a scalar multiple, if you have b times f of x, you're just going to multiply b to that limit there. Sum of the difference, so if you see f of x plus g of x, you're just going to add them or subtract them. For product, you're going to multiply them together, and then for quotient, you'll divide them, and then power, you're going to just do the power to it. So hopefully that makes sense. When evaluating limits, remember that there are several ways to solve most problems. Often a problem can be solved numerically, graphically, or algebraically. A graphing utility can be used to confirm limits numerically with the table feature or graphically with the zoom and trace features. And so I will show you how to do that in Desmos. So it'll be screencastify that I will do. And then you'll be able to see how do you plug it into Desmos and how do you get the table out of that, and then editing the x values so you can get the y values that you want. Let's try these examples with direct substitution and properties of limits. We're going to find each limit. So here we're just going to substitute it directly. So we have the limit as x approaches 4 of x squared. Now we can plug it in because we're not going to get something like over 0. It's not going to be undefined. So we just plug it in directly. So it's 4 to the square, which is 16. For this example, it's 5 times 4, so this is 20. Now for this example, we get tangent of pi over pi. So remember tangent, tangent is sine over cosine first of all. And then so you can think about sine of pi, cosine pi, however you want to think about that, or think about the value at pi. And that is x is -1, y is 0. So tangent of pi is 0 over -1 over pi, or just 0 over pi, or 0. For letter D, as x approaches 9, we are going to get 3. For here, we get the limit of x cosine x as x approaches pi, so pi cosine pi. So pi cosine of pi is -1, so therefore this answer is -pi. For letter C, so 3 plus 4 squared is 7 squared, or 49. So try these examples down here. Find each limit. Let's try this out. Letter A, you should have gotten 1 over 4. So notice that it's the exact number that it is as x approaches c, so going back to here. So notice if you have x approaches c of b, it just equals b, so that's exactly that example here. So that's what that means here. Then letter B, we have as x approaches 3, we have 27. For C, we have -1 over pi. For D is 2 square root of 3. Letter E is 0, and letter F is 4. Now let's look at limits of polynomial and rational functions. So if p is a polynomial function and c is a real number, then p of x as x approaches c is p of c. If r is a rational function, r of x equals p of x over q of x, and c is a real number such that q of c is not 0, then the limit of r of x as x approaches c equals r of c, or that is p of c over q of c. Now we're just going to find each limit by direct substitutions. We're not factoring or doing anything like that yet. We're just plugging everything in and finding out what the answer is. So letter A, let's just plug it in. -1 squared plus -1 minus 6. So this is 1 minus 1 minus 6, so the answer is negative 6. For letter B, let's plug in negative 1. So negative 1 cubed minus 5 times negative 1 over negative 1. So it's negative 1 plus 5 over negative 1, or 4 over negative 1, or negative 4. Letter C, this is negative 1 squared plus negative 1 minus 6 over negative 1 plus 3. So it's 1 minus 6 over 2, or negative 6 over 2, or negative 3. So try out these examples here. Just plug it in and find out the limit for each. So plugging this in, you would get A, which is 7. Letter B is 7 over 3. And letter C is 1 over 3.